Hello everyone, welcome to the second lesson of the second term. Today we are discussing about vertical projectile motion. So we're going to consider an object that is projected from a height that is above the ground and falls to the ground which is below the starting point. We're also going to consider a motion for an object that bounces off. An object is projected from a height and falls back to the ground, which is below the starting point. So up is taken as positive, which means G is negative 9.8 meters per second squared. So the object has a non-zero initial velocity, which is greater than 0 since up is taken as positive. As the object falls, its velocity increases because it is falling in the direction of gravity. As the object goes up, its velocity decreases because it is moving against gravity. At the maximum height, the object stops. Then it turns around and falls. Delta y, which is the displacement of the object, is the same as the height of the starting point. But it is downwards because that displacement is covered while the object is falling. The final velocity is greater than the initial velocity, but it is in the opposite direction, which means it is negative. T, which is the time taken for the entire motion, it is the same as the time taken up plus the time taken to fall. This is the graph that represents the entire motion of the object. So the object starts from a height h above the ground at the position A. As the object goes up, its velocity decreases because it is moving against gravity until it reaches a maximum height at point B. Then it stops at point B, then it falls. As it falls, the object now is moving in the direction of gravity, which means its velocity increases until it passes the starting point, which is point C. So the velocity of the object at point C is the same as the initial velocity at point A, but it is downwards in the opposite direction. So the object hits the ground at point D, at the biggest velocity of the object. This is how the graphs looks like. The first graph is the position time graph. Along the x-axis, we have the time that is taken in seconds. Along the y-axis, we have the displacement of the object in meters. This is the starting point. Displacement is 0, which means the starting point is taken as the point of reference. So this is the maximum height. Then here the object passes the starting point and the object hits the ground here. The second graph is the velocity time graph. So we have time along the x-axis and we have velocity in meters per second along the y-axis. Initially, the object is projected here with the initial velocity. As it goes up, the velocity of the object decreases until it is 0 at the maximum height. Then the object starts falling until it hits the ground. As you can see, the area here is negative. The negative area is bigger than the positive area, simply because the object covers more distance when it falls than when it rises up. So remember, the area represents the displacement that is covered by the object. The third graph is the acceleration time graph. Along the x-axis, we have the time, which is measured in seconds, and acceleration along the y-axis, which is measured in meters per second squared. So the graph of acceleration time graph is constant, which is negative 9.8. Okay, let's consider the examples together. A ball is thrown vertically upwards from a height of 12 meters above the ground with a speed of 15 meters per second. We need to calculate the maximum height reached by the ball. We calculate the time taken to reach the maximum height. We also calculate the speed of the ball when it hits the ground. 1.4, we calculate the time taken by the ball in the air, which is the time for the entire motion. 1.5, we need to sketch the position time graph, the velocity time graph, and the acceleration time graph. Okay, let's answer the questions together. This is example number 1. So what are we given? We're given the initial velocity, which is 15 meters per second upwards. So we're also given the final velocity, which is 0 meters per second when the object reaches the maximum height. Then g is constant, which is 9,8 meters per second squared, and it is acting downwards. Okay, let's consider the formula to use. We take up as positive. So we can use this formula that will contain what is given, which is initial velocity, final velocity, g, and what we are looking for, which is the displacement. So we can use v final squared equal to v initial squared plus 2g delta y. Let's make substitution. The final velocity is 0. We substitute the initial velocity, it is 15. We take 15 as positive because it is upwards. Then g is negative 9,8. It is downwards, taken as negative. 0 squared is 0. 15 squared is 225. Positive 2 times negative 9,8. Positive times negative is negative. 2 times 9,8 is 19,6 delta y. Then we can take this negative term to the left and it becomes positive. So we're looking for delta y. We need to make it the subject of the formula. Then we can divide both sides by 19,8. We divide both sides by 19,6. Okay, to get displacement, 225 divided by 19,6. How much is it? It is 11,48 meters. That is the displacement. Okay, the second question is to calculate the time that is taken to reach a maximum height. That is 1.2. Okay, so we can use this formula. V final equal to V initial plus G delta T. Let's substitute final. Velocity is 0. Initial is 15. G is negative 9,8. Then delta T. Take up as positive and down as negative. You can take the negative term to the right and it becomes positive. So equal to 15. So we don't even need to indicate it as positive, since 9,8 delta T is the first term. Then to make T the subject of the formula, we can divide both sides by 9,8. Then the answer is 15 divided by 9,8, which is the same as 1,53 seconds. That is the time taken by the object to reach the maximum height. 1.3. We need to calculate the velocity of the object when it hits the ground. You can use this formula, V final squared equal to V initial squared. Plus 2g delta y. Let's substitute V final as what we are looking for. We take up as positive and we take down as negative. So the displacement is covered while the object is falling, so it is negative. So here 15 squared plus 2 times negative 9,8 times negative 12 gives us 460,2. But this is V final squared, but we're looking for V final. So we need to make V final the subject of the formula. What do we do to cancel the square? So we apply the square root both sides. Then we get V final, which is the same as 21,45 meters per second. Okay, let's now go to question 1.4. Question 1.4, we need to calculate the time taken by the object in the air. time taken by the ball in the air. So which formula to use? We can use this formula V final equal to V initial plus G delta T. Okay, let's substitute. We know the final velocity of calculated it is negative 21,45. We take down as negative. The initial is upwards, it is positive 50. G is downwards, it is negative 9,8. Then delta T. Then we can take this term with T to the left, it becomes positive 9,8 delta T. Then we take negative 21 to the right, it becomes positive 21,45. Then to make T the subject of the formula, we can divide both sides by 9,8. Then we get our delta T, which is 3,70 seconds. Okay, let's go now to 1.5. 1,5. We need to sketch. The first question is to sketch the position time graph. Position time graph. So along the x-axis, we have time in seconds, and along the y-axis, we have the displacement in meters. Okay, so the biggest value, of course, is 12, which is the height. So we can use a scale of 2. So 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. Negative 2, negative 4, negative 6, 8, 10, 12. So we take the starting point as the point of reference. So which means here, displacement at the starting point is 0. The object goes up until it reaches, can estimate 11,480 somewhere there. So we can estimate 11,48 there. Then the object hits the ground here at 12. So the object goes up until it reaches the maximum height there, which is 11,480. Then the object falls and hits the ground. Okay, at maximum height, we have the time, which is 1,53. When the object passes the starting point, the time is double 1,53, which is 3,06. When the object hits the ground, so the time there is 3,72. We have calculated it. Okay. Let's go to the second sketch, 1.5.2, which is the velocity time graph. Along the x-axis, we have time in seconds. Along the y-axis, we have v meters per second. Of course, the biggest velocity, you can take the scale of 5. The biggest velocity is 15, 5, 10, 15. That is biggest velocity upwards. Downwards, the biggest velocity is 21,45. So you can say 5, 10, 15, 20, 25. This is negative 5, negative 10, negative 15, negative 20, negative 25. Okay, at the starting point, initial velocity is 15. So it decreases as the object goes up until the maximum height. Then it falls from 0 as if it is dropped until it hits the ground. So we can estimate somewhere there. Can estimate 21,45. Okay, the time here is 1,53. When the object on its way down passes the starting point, the velocity is 15 downwards in the opposite direction. Then the time will be 3,06. When the object hits the ground, the time is 3,17. That is the velocity time graph. Let's now sketch the last graph, 1.5.3. Okay, acceleration time graph. You can write acceleration as G or as A. So along x-axis, we have time measured in seconds. Along y-axis, we have acceleration measured in meters per second. So downwards is taken as negative. So the acceleration here is negative 9,8. And at the end, of course, the time is 3,72. Okay, that is the sketch for the acceleration time graph. Let's now go back to our notes. All right, learner's activity. Please do this by yourself at home. The velocity time graph shown below represents the motion of two objects, A and B, released from the same height. Object A is released from rest, and at the same instant, object B is projected vertically upwards. You need to ignore the effects of friction. So here we're given the graph which represents the motion of both object A and object B. First question, object A undergoes a constant acceleration. Give a reason for this statement by referring to the graph. No calculations are required. 1.2. At what time is the speed of the object B equal to 10 meters per second? 1.3. Object A strikes the ground after 4 seconds. Use the equations of motions to calculate the height from which the objects were released. Question number 1.4. What physical quantity is represented by the area between the graph and the time axis for each of the graphs A and B? Calculate without using equations of motion the distance between objects A and B at time equal to 1 second. 1.6. On the same set of axes, sketch the position time graph for both objects. Let's now consider a bouncing object. An object that falls from rest and bounces back. So we're going to consider an object that is falling from rest, which means an object that is dropped. So for bouncing object, we don't need to consider an object that is dropped, an object that is projected downwards, and an object that is thrown upwards. So we can just take one example because the concept of bouncing back is the same. So we're just going to consider one example, which is an object that is dropped. So we recommend that we take downwards as positive. Okay, let's take downwards as positive. Then which means G is positive 9,8. You can also take up since the object is going to bounce. So you can even take up as positive. But for the first phase, we can take down as positive. The first phase, it is when the object is dropped until it hits the ground. Then on the first phase, we can take down as positive. But on the entire motion now, we take down as negative. So the initial velocity of the object is 0 because the object is dropped. The velocity of an object is maximum when it hits the ground. The object has a downward displacement that is equal to the height of the point it falls from. As the object falls from the initial velocity of 0, its velocity increases until it hits the ground. The object experiences a positive acceleration during the time of impact. impulse of the ground on the object causes a change in momentum, which means the speed of the object changes and it decreases. The collision between the ground and the object is inelastic, hence the kinetic energy is not conserved. Some energy is transferred into heat and sound. The object will not bounce back to the height of the starting point because there is a certain amount of energy that is lost. As the object rises up, it slows down until it stops at the maximum height after the first bounce. The motion will repeat itself for a few bounces. After every bounce, the object will reach a lower maximum height because the energy is lost during the collision. During the impact, the object is not under free fall, which means during collision, the object is not under free fall because there is an external force that is acting as a result of the collision. Free fall motion are divided into phases as shown below. So the object is dropped from point P, so it falls. As it falls, its velocity increases until it hits the ground. So we have A here, point A, and this is point B. Then here we have point C, and here we have point D. Then at the end we have point E. So the first phase is from point P up to point A when the object hits the ground. It's free fall, that is the first phase. The first phase is when the object leaves the ground until it hits the ground again at point C. Then from point D, the object, after the second bounce, it leaves the ground and hits the ground again at point A. That is another phase. So we have the first phase here, the second phase, and the third phase. Let's consider the graphs. So this is the position time graph. The object will fall and hit the ground. Here, the object is in contact with the ground, then the object bounces. This is the velocity time graph. So for the entire motion, you can take down as negative. Then the object initially leaves the starting point, it hits the ground. Here it is in contact with the ground, then it bounces with a velocity that is positive, which is upwards. Then it reaches the maximum height. Okay, let's consider now the example. Example number 2. A man is standing in a hot air balloon that is moving straight up at a constant speed of 4 meters per second. He drops a ball that takes 3 seconds to hit the ground. So example 2, the ball bounces back twice to reach maximum height of 6 meters and 8 meters respectively. The first question is, what is the initial velocity of the ball? 2.2. Is the hot air balloon in free fall? Give a reason for your answer. 2.3. Calculate the height of the hot air balloon when the ball was dropped. The velocity of the ball when it hits the ground. Then 2.4. After the first bounce, calculate the velocity of the ball when it leaves the ground. Calculate the time taken to reach the maximum height. Then after the second bounce, calculate the velocity of the ball when it leaves the ground. Then we need to calculate the time taken to reach the maximum height. Then 2.6, we draw the position time graph, the velocity time graph, and the acceleration time graph. Okay, let's answer the questions together. Example number 2. Okay, the first question. What is the initial velocity of the ball? So of course the ball takes the initial velocity, which is the velocity of the air balloon. So it's 4 meters per second and it is upwards. Okay, the second question is the hot air balloon in free fall? The answer is no. What is the reason? Because the net force acting on the balloon is zero. How do we know? Because the balloon is moving at a constant speed. Or we can say the balloon is not accelerating at gravitational acceleration, which is 9.8 meters per second. Okay, question 2.3. Calculate the height of the hot air balloon when the object was dropped. Okay, so the initial velocity is given there. It is 4 meters per second and it is upwards. Then the time taken by the ball is 3 seconds in the air. Then G is 9.8 meters per second squared and it is downwards. Okay, so which means we use here the ball to calculate the height of the balloon when the ball was dropped. So we use the entire motion here. So let's use this formula, delta y equal to V initial delta t plus half G delta t squared. Let's substitute the known values. We take up as positive. So the initial velocity is upwards, positive 4. The time is 3. G is downwards, is taken as negative 9.8. T is 3. So it's square. Let's punch a calculator there. So the answer is negative 32.1 meters. So we can say therefore the height is equal to 32.1 meters above the ground. That is the height. Okay, the second question is calculate the velocity of the ball when it hits the ground. Calculate the velocity of the ball when it hits the ground. That is 2.3.2. Which formula to use? We can use V final equal to V initial plus G delta t. Let's substitute the initial velocity is 4. We take up as positive. G is negative 9.8. We take down as negative. T is 3. What is the answer? Let's make calculations. So the answer is negative 25.4 meters per second, which means it is 25.4 meters per second downwards. So it is negative because it is acting downwards. Okay, question 2.4. What is question 2.4? Calculate the initial velocity after the first bounce. We need to calculate the velocity of the ball when it leaves the ground after the first bounce. Okay, that is 2.41. So the initial velocity is what we are looking for. So G, we know, is constant and it is 9.8 meters per second squared and is acting downwards. So we know when the object reaches the maximum height, the velocity is 0. Okay, the object bounces off into a maximum height of 16 meters above the ground. Okay, which formula to use? We can use V final squared equal to V initial squared plus 2G delta Y. Okay, let's substitute everything that we know. Final velocity is 0. Initial is what we are looking for. G is 9,8. It is downwards. We substitute with negative. Delta Y is 16. It is upwards, so it's positive. So which means we have initial velocity squared, which is equal to 2 times 9,8 times 16. Then you can apply the square root both sides to make the initial velocity the subject of the formula. Then you get our V initial, which is how much? The square root of 2 times 9,8 times 16. So which is 17,71 meters per second. So the second question is to calculate the time taken by the object to reach the maximum height after the first bounce. So this is 2.4.2. So you can use this formula, V final equal to V initial plus G delta T. Final velocity at maximum height is 0. So we've managed to calculate the initial velocity, which is 17,71. Plus downward is negative, so it's 9,8 delta T. So let's take the negative term with T to the left, it becomes positive 9,8 delta T equal to 17,71. Then you can divide both sides by 9,8. Okay, so what is delta T? Delta T is 17,71 divided by 9,8, which is the same as 1,81 seconds. Okay, that is 2.4.2. Let's go to 2.5. 2.5. After the second bounce, calculate the velocity of the ball when it leaves the ground. Okay, so we're looking for the initial velocity when the object leaves the ground. But at maximum height, we know that the final velocity is 0. G, we know is constant. It is 9,8 meters per second, and it is acting downwards. So after the second bounce, we know that the object reaches a height of 8 meters. Okay, we can use this formula, V final equal to V initial squared plus 2G delta Y. Let's substitute. Final velocity is 0. Initial velocity is what you are looking for. G is downwards, so substitute negative. Then delta Y is upwards, then it is positive. Okay, so V initial be equal to 2 into 9,8 times 8. Then to get V initial, we can apply the square root to cancel the square. So we do that both sides, in the left-hand side and also in the right-hand side. Okay, let's punch our calculator, the square root of 2 times 9,8 times 8. So it gives us 12,52 meters per second. Okay, the next question is to calculate the time taken to reach the maximum height, which is 2.5.2. Okay, we can use this formula, V final equal to V initial plus G delta T. Okay, let's substitute. Final velocity at maximum height is 0. The initial velocity when the object bounces off, we got it in the previous question, is 12,52. Then G is downwards, which is negative 9,8. So you can take the term with T to the left, it becomes positive. Then to get t, we can divide both sides by 9,8 to make t the subject of the formula. What is 12,52 divided by 9,8? It is 1,28 seconds. Okay, let's go to the next question. The next question, 2.6, is to draw. We need to draw position time graph, velocity time graph, and the acceleration time graph. 2.6.1, the position time graph. Okay, let's sketch. So along the x-axis, we have time measured in seconds. So along y-axis, we have the displacement measured in meters. Okay, the biggest, of course, is the height, which was 32,1. Okay, we can use a scale of 5, 10, 15, 20, 25, 30, 35. Okay, so let's take the starting point as the point of reference. Okay, let's take the starting point as the point of reference. We can estimate 32 somewhere there above 30. This is 32,1. Okay, so the object went up. So we didn't calculate the maximum height reached by the ball. Then the object fell to the ground. The object is in contact with the ground. The object bounces to a height of 16, estimated there. The object bounces to a height of 16, it falls, the object is in contact with the ground, the object bounces again to a height of 80, estimated there, and the object comes to the ground. So let's estimate this is 80. Okay, that is how the graph looks like for the displacement time graph. Let's now go to the second graph, 2.6.2, which is the velocity time graph. Okay. So along the x-axis, we have time in seconds. Then along y-axis, we have v in meters per second. Okay, the biggest velocity upwards was 17,71 when the object bounces after the first bounce. The biggest velocity was when the object hits the ground. So again, we can use a scale of 5, let's say 5, 10, 15, 20. -5, -10, -15, -20, -25. The initial velocity of the object is upwards, and it is here at 4. We can estimate 4 just below 5. So initially the object is falling down until somewhere there it hits the ground at 25,4. So we draw a straight line there, it must be a straight line. Then the object hits the ground Here, after 3 seconds, then it is in contact with the ground. Then it bounces off with an initial velocity of 17,71. Then the object falls until it hits the ground. Of course, it will hit the ground with the same velocity. You can estimate it there of negative 17,71. It's a straight line, so the gradient should be the same here because the gradient represents the acceleration, which is constant. So the ball again bounces off the velocity of 12,52. It's estimated there between 10 and 15. So this is 12,52. So the object will fall, reaches the maximum height, and hit the ground with the same velocity. Same velocity of negative 12,52. Okay, this is how the graph looks like. Okay, so now let's go to the last question, 2.6.3, which is to sketch the acceleration time graph. Along x-axis, we have time in seconds. Then along y-axis, we have acceleration in meters per second. So we have taken down as negative. So acceleration is 9,8, which is negative. So there is no need for acceleration to use a scale. So the object, the acceleration is constant. Then the object here hits the ground. Then we have a positive acceleration. Then here the object is in contact with the ground. That is the first bounce. The object hits the ground again, we have a positive acceleration. Then yeah, this is the acceleration time graph. This is how it looks like. Okay, let's go back to our notes. So also if you won't be penalized if you draw acceleration without showing the bounce. So you can also draw it as follows. So as negative 9,8. Then here we have G in meters per second squared. You can also draw it here like that. Okay, let's go back to the notes together. Okay, learners activity number 2. You need to do it at home by yourself. Jane, who is on top of a building, projected the ball vertically upwards. Just before the ball hits the hard surface, it has a velocity with magnitude 15 meters per second. The ball bounces back vertically on a hard surface. Immediately after bouncing, it has a velocity of 10 meters per second, which is upwards. The graph shows the velocity of the ball against the time from the moment it is thrown upwards until it reaches the maximum height again after bouncing the first time. So we're given there the velocity time graph. Questions 2.1. What is the velocity of the ball when Jane initially throws it upwards? 2.2. What do we determine by calculating the gradient of the graph during the first 2 seconds? 2.3. Calculate the gradient of the graph in the first 2 seconds. 2.4. Without using the equations of motion, calculate the height of the building. 2.5. Calculate the time it will take the ball to reach the maximum height after the first bounce, from the moment Jane throws it upwards. 2.6. Draw the displacement time graph for the motion of the ball from the time it is projected to the time it bounces to the maximum height. You need to show the height of the building, the maximum height reached by the ball, the maximum height reached after the first bounce, the time taken by the ball to reach the maximum height before and after the first bounce. Okay, learners activity number 3. A ball A is thrown vertically upwards from a height h with a speed of 15 meters per second. At the same instant, a second identical ball B is dropped from the same height as ball A, as shown in the diagram below. Both balls undergo free fall and eventually hit the ground. So we have the motion there. The first ball is object A. It's ball A, which is thrown from that height. Then we have B. Calculations. Calculate the time it takes for ball A to return to the starting point. 3.2. Calculate the distance between ball A and ball B when ball A is at its maximum height. Calculate the speed of ball A when it hits the ground. Calculate the speed of ball B when it hits the ground. 3.4. Calculate the time taken by ball A to hit the ground. 3.42. Calculate the time taken by ball B to hit the ground. 3.5. On the same set of axes, draw the velocity time graph for the entire motion of both balls A and B. Clearly show the following on your graph. Show the initial velocity of both balls. Show the time taken by ball A to reach its maximum height and to return to its certain height. You need to show also the time taken by both balls to hit the ground. Okay, ladies and gentlemen, that is the end of the lesson. Thanks for taking part of the lesson. All the best. Learn, grow, and succeed. Thank you.